Here's the basic idea. In the CNN we use a trick of common parameters for many neurons. Additionally, we also exploited certain structure. Can we do the same two things with recurrent neural networks? We want a neuron's input at any time step to depend on its state s at time t minus 1. Now, I must mention that time here is only one possible instance of the sequence. In general, the time t could be replaced, or generally with say index t, and an important example, a running example for the discussion that follows will be that of language models. So let's say you see me writing a sentence here, replay REPLAC. Could you now predict what the next character should be? Well, the next character was an E, but what are the other possibilities? There aren't too many other possibilities. So let's say E was the most probable one, and now that I have an E here, if I ask you to predict the next character, either you would have a space or you might put a D, and given that I've already predicted replaced, what would be the next character? Generally I would require, so I would have otherwise predicted a W, but when I happen to see M, O, I immediately am going to change my inference on the following characters. So as you can see, we want a neuron's output at time t to depend on its state s at time t minus 1. We also want it to depend on any inputs that have been seen at the current time step directly. Inputs or signals from the previous time steps or previous position indices will be only indirectly reflected through the state at the previous indices. The other point that we realize in this example is the model that was used to predict an E or a D should not be drastically different from the model that was used to predict an O when you see an M. So the second point here is we would like the same model to recur, the same parameters to be reused. So share parameters across time steps, and that basically means the O that gets predicted after seeing an M is based on the same kind of model, same parameters that predict an E after having seen a C or a D based on the prediction E and after having seen a C, and so on. So that is what we refer to as recurrent. We are performing the same task for every element of the sequence. How would such a model look like? So yes, indeed what we want here is the ability to capture the current input, and this is what the input layer of a traditional neural network will give you. So based on the current input, I'm going to make a bunch of predictions through a hidden layer. So I might have a hidden layer here with H1, H2 and so on, and based on the hidden layer, of course, I can make an output prediction. What is desired here is that the state of the hidden layers after seeing new input is somewhat associated or determined by the state of the hidden layer after having seen the previous input. So let's show the same. So here's my new input, and I'm going to connect the same network architecture, the input nodes to the hidden nodes, they will determine the output. Now some points to realize here are that these two are exactly the same network architecture. However, what we want is this new hidden state depends on the previous hidden state. So question is how to encode this dependence. Well, one could do this as follows. One could associate weights for transition from a particular state st minus 1 of a perceptron to another state st of the same perceptron. So again, what you see here are the same perceptron, the same network, but at different time steps. Now the weight associated for transition from st minus 1 to st and the weight associated for transition from st to st plus 1 of the same neuron are kind of dependent on the time. Is that really required? Well, what we wanted or we expressed as a desirable property of the recurrent neural network on our previous slide was that these parameters are actually shared, and that's exactly what we depict here on the right hand side. We not only impose a structural requirement, we also talk of shared parameters, which is what makes the network recurrent, performing the same task for every element of sequence while sharing parameters. Is there a way we can reflect this property into the physical neural network? So here's the question we want to address next. Is there a way we can integrate this functional property into the network, the neural network, as a structural property? So question basically is how do we translate this functional property into a structural property?